Hello everybody. Lesson 11 part 1. Topic Organics. Soil as a material. From an engineering perspective, soil can be defined as a material that can be worked without drilling or blasting and consists of relatively soft, loose, uncemented deposits such as gravels, sands, salts, and clays. Soil is one of the most important materials in construction. However, it's often neglected in other construction materials textbooks. It's one of the most variable materials to consider as it's naturally occurring. Also, it will be almost certainly inconsistent from one side to the next. The most important elements to consider are the range of soils, their properties or parameters, and what causes variations in these values. Soil formation and soil horizon. A typical ground profile is illustrated in a figure, and soil can be classified into 4 main groups. Agricultural soil or topsoil, our line subsoil. The second, engineering soil. The next, organic soil. And the last, field of made ground. And now more detailed about all the group. So agricultural soil, that is topsoil or subsoil, may be organic in nature, peat, for example, and not considered as engineering soils. The next, second group, engineering soil, that is gravels, sands, salts, and clays, consists of soft, loose, uncemented deposits. The next group of soil is organic soil, is formed from the decomposition of vegetable matter. For example, topsoil and peat, that can be sands, silts, and clay, may also contain organic matter. Soil containing organic matter are unsuitable for engineering purposes. Typically, they are weak and subject to large settlement. And the last group of soil is field or made ground. This is material that has been placed in a semi-controlled manner, such as embankments and a controlled landfill. So here we can see typical ground profiles. At any stage, the water table could be anchored, uncontoured, up a zone of the soil which is fully saturated. If this is a ground level, the next soil, this is agricultural soil, engineering soil, and bed rock. Volume composition of a desirable surface soil. 50% of surface soil is a solid material, and from 45 to 48% this is a mineral matter, and 5% this is organic matter. 25% of surface soil is water, and 25% is air, and all this a pore space, you can say. And we understand that rock is a hard, rigid cemented deposit and is grouped according to how it has been formed. There are three main types of rocks: igneous rocks, metamorphic rocks, and sedimentary rock. Igneous rocks are those that solidify from the magma through either intrusive or extrusive processes. Extrusive rocks form when magma cools rapidly on the Earth's crust. Intrusive rocks are formed when magma cools very slowly within the Earth's crust. Metamorphic rocks are those that have been altered by heat and or pressure, so that they have lost their original character. They have often been recrystallized to form new rock type. And sedimentary rocks result from external forces on the Earth's crust and are formed from particles deposited by rivers, glaciers, the wind, the sea, or by chemical deposition from lakes or the sea. Soil parent material and weathering. The mineral material of a soil is the product of the weathering of underlying rock in place, or the weathering of rock particles. The material from which a soil has formed is called its parent materials. The rate of weathering depends on the chemical composition of the materials that comprise the rock, the type, strength, and durability of the material, the extent of rock defects, and the extent and type of vegetation and the surface. Principal master soil horizons are: a horizon or mineral surface soil. If the soil has been plowed, this is called the up horizon. B. Horizon or subsoil. And C. Horizon or partially weathered parent material. Rock, R, or unconsolidated parent materials similar to that from which the soil developed. And now about surface soil horizon up or A. Up or A horizons contains more organic matter than the other soil layers, often coarser than the subsoil layer. A or F horizon tends to be more fertile and have a greater concentration of plant roots than any other soil horizon. Subsurface soil horizon. B horizon. Typically finer in texture, denser and firmer than the surface soil. Organic matter content tends to be much lower than surface layer. Subsoil colors are often stronger and brighter. Shades of red, brown and yellow due to iron in clays and other particles. Subsoil layers with high clay accumulation. This is example of Jim Baker, Virginia Tech. Subsurface soil horizons. C horizon. Partially decomposed and weathered parent material that retains some characteristics of the parent material, more similar with the parent material from which it has weathered than the subsoil above it. Idealized soil profile. The first the first soil layer, loose, easily recognizable organic debris. The next layer, partially decomposed organic materials. Then fully decomposed organic material. The next, A layer, surface mineral horizon, darker and higher in organic matter. If plowed, will be designated EP. Elevated horizon, light colored zone of maximum leaching of clay, iron, aluminium and soluble organic matter, often mixed into EP. Transit from A to B, more like E than B. Then transition from E to B, more like B than E. And then subsurface zone of maximum accumulation of clay, iron, etc. Common features include development of blockly and or prismatic structure, clay coating on larger particles, red and yellow colors from accumulation of iron oxides. The next transition from B to C, more like B than C. And the next C. This is a weathered parent material such as saprolite, oxidizing sediments, unconsolidated bedrock, etc. And rock are formed from minerals. For example, granites equals feldspar plus quartz plus mica and plus amphibole, a collection of different minerals. The next hard bedrock and not always seen. A mineral is a naturally occurring, inorganic, non-living substance. Mineralogy is the identification of minerals and the study of their properties, origin, and classification. There are approximately 3,000 minerals, and each mineral has a particular chemical composition which can be expressed as a chemical formula. The majority of minerals are compounds comprising two or more elements. For example, nitrichlor, which comprises sodium and chlorine to form sodium chloride or halite. A small number of minerals contain just one element, copper, gold, or sulfur. Soil physical properties and organic matter. Sand. So soil particles, and first particle is sand. Particles range in size from very fine 0.05 millimeter to very coarse 2 millimeter in average diameters. Most particles can be seen without a magnifying glass. This photo illustrates a sand texture in Virginia. This is a very coarse sand, 2 millimeter in average diameter. The next particle is silt. Particles range in size from 0.05 millimeter to 0.002 millimeter. Cannot usually be seen by the unaided eye. When moistened, silt feels smooth. When dry, it's smooth and fluffy. As this figure shows, silt loam texture. Clay. So you can see here a clay texture, and clay particles are finer than 0.002 millimeter. Can be seen only with the aid of an electron microscope. Feels extremely smooth and powdery when dry, and becomes plastic and sticky when wet. The soil triangle. In reality, a soil may contain a mixture of particles. This can be represented by the soil triangle. Here you can see a percent clay from 0 to 100%. The percent silt and the percent sand. And here you can see a sand, loamy sand, sandy loam, sandy clay loam, sandy clay, and clay. Then silty clay loam, silt loam, and silt. And here silt loam, loam, sandy loam, loam sand, and sand. Soil structure. Soil is a collection of soil individual particles forming a porous structure. The pores or voids which contain air and or water depending on the saturation state of the soil. The individual particles can move relative to each other. However, in a rock mass, the grains cannot move. Soil is therefore regarded as a particulate system. Within the soil structure, air is unimportant from an engineering point of view. However, air voids should be reduced as far as possible by the process of compaction. Water is, however, very important for the engineering properties and behavior, particularly for cohesive soils. The solid material, that is the soil skeleton, varies widely in particle shape, size, and mineral composition, and can contain both organic and inorganic matter. So, soil aggregation is a cementing of several soil particles into a secondary unit or aggregate. Soil particles are grouped together during the aggregation process to form structural units. These units vary in size, shape, and strength. Soil is classified by determining a number of fundamental parameters which is defined by building standard as moisture content, consistency limits, liquid limits, plastic limit, plasticity index, shrinkage limit, density like linear measurement, immersion in water, water displacement, sand replacement, core cutter, particle density like gas jar, pycnometer, and particle size distribution, dry sieve or wet sieve.